Let's start out with number 9 because I already messed up number 1. Cosine, given f of x equals cosine of pi over 3 plus pi minus 2, and given negative 1.5 on the interval at 0.5. On which interval is f of x greater than g equals x? Okay. So what is this question asking? We're given two functions, right? G of x and f of x. It's asking me, when is this line, when is the function when it goes like, and then it's this one, it's going to go like, it's a straight line. When is this function, what intervals are greater on f of x, okay? So I don't have a graphing calculator with me here. But as you can imagine, you go into the calculator, go y equals cosine of x over 3 plus pi minus 2, and then you put in y equals 1.5. You tell it to go graph, and I can actually show you this here on the computer. Let's go to graphing calculator. Sorry, I'll just do this. y equals cosine of x divided by 3 plus 5 minus 2, and then we'll put in the other one, y equals negative 1.225. So you can see here that and if we're not going to use Desmos, but if you're on the AP test, you could go x equals 4 pi, just to make sure, because we're not on the AP test, shouldn't be given Desmos. I don't know if you're taking the AP test, but yeah. So from here, this is f of x, to here, where is f of x greater? All right, and so where's g of x greater? My apologies. Where's g of x greater? It starts from here, 0 to 7.25. All right, and where does it intersect again? 1.75 to 4 pi. Okay, if we're on the calculator, all you have to do is go to second calc, you go to intersection, put this point, guess where it is, it'll tell you on the calculator, then you do it again for right here, and then now that's all you have to do. Okay. This one is going to be this other one right here. Okay, this one's tricky. Convert the rectangular one into polar form. All right, let's see. Let me get this angle here. All right. Now, this one is going to be the most difficult one on the entire test. So, well. As you can see, I was having some difficulties with it, but I figured it out. So, start here. The equation is, convert the equation, x squared plus y minus 4 squared equals 16. How are we going to get this into polar form? Well, what do we want to find? We want to find r, we want to find theta, okay? And so, let's start. First thing we're going to do is we're going to distribute this to x squared plus, and let's remember now, when we mean distribute the 2, it doesn't mean put this in parentheses in the calculator, because it's not going to give you the right answer. It should be y squared minus 8y plus 16, okay? Equals 16. All right. And so well, okay, before we get there, we write this x squared plus y squared minus 8y plus 16. First thing we can do, we can subtract 16 on both sides. All right, and this is important because we want to get both sides equal to 0. And just in reference tomorrow, when you FOIL out, sometimes this x squared is going to be like in this where it's in parentheses as well. If this one is in parentheses as well and you FOIL it out, the two numbers, the numbers without a variable next to them, so this 16, if there's no one here, they should add up to be this number. You always want to get this number to subtract to the side and equal 0. So let's rewrite it as x squared plus y squared equals 80. All right. So we have 0 now. Okay, now this is a big one. Let's go look back at our identities. Let me bust out the workbook real quick. In our workbook, it says that for the Pythagorean identities, that I'm trying to find it in the workbook here. Not in here. Give me a second. Okay, right here. Right here. This, to change the rectangle to polar coordinates, you can do x squared plus y squared. Well, let's look at this equation. What do we have right here? X squared plus x squared plus y squared. So if, just like we did yesterday with our polar equations and I'm proving identities, if x squared plus y squared equals r squared, then we can just sub in r squared right in here in this equation to find r. So r squared minus 8y equals 0. But still, we're not done yet. Now that we subbed it in, we need to figure out, obviously the equation wants us to have cosine and sine. Well, this is important as well because which one is sine? Is it cosine or sine? It's sine. All right, so r squared minus 8 sine of theta equals 0. Well, actually it's r sine, my apologies. All right. Why do we need to do this? It's because polar form is expressed in sine and r of sine, r of cosine. And so there needs to be a theta value. There's no x's and y's. It's r sines and r cosines and r tangents or whatever. All right. So we need to get it here. And then from here, we have an r here. We have an r here. What we're going to do with that r is we're going to pull it out of the equation, essentially. So we're going to do r minus 8 sine of theta equals 0. All right. And then that's pretty much all we have to do. Neither of these have unit circle identities. And so we're going to just plug this in to find our equations. My apologies, I don't know what I'm doing. Well, this is now broken into two parts. We need to find what r equals, right? So if r equals 0, because this, you know how we did the thing last year, where it's like if you have a number on the outside of the parentheses and you have to set it to equal to 0, r is going to equal 0. And we're also going to take this one in here. So r is going to equal r minus 8 sine 0. Well, we're just going to add r to the other sine to the other side. So r equals 8 sine of theta. That's all you can do. That's all you can do. So r is just going to equal 8 sine. And that 8 sine of theta, and that is your answer. That is all you need to have. So to recap, let's remember our polar rectangular to coordinate form identities. So r squared equals x squared plus y squared. If you see x squared plus y squared, it's going to equal r squared. Gotta convert these x's and y's into r sines and x cosines, r cosines, and when you're likely gonna have to factor out an r tomorrow. Set the r's equal to 0. So r equals 0, r equals r times minus r minus 8 sine theta equals 0. Flip the r to the other side. That's all you can do. So your answer is going to be this. I believe I got it. Yeah, r equals 0, r equals 8 sine. Okay. This one, for given r equals 4, this is not that hard. It's kind of the same thing as we did on the first problem I showed you. 4 sine 2. Just plug this into the calculator, and then set on the calculator. You can put the range of it. If you go to the windows, whenever you go to the x max, put the minimum in for 0, put the maximum in for 2 pi. You just do 2 pi, it'll automatically substitute in for you. And so state the intervals where the positive, okay, this is actually a little bit difficult. So, you know how what's it called? When the interval is, okay, this is obvious. When it's above the x equals 0 line, whatever, right? If it's over here, it's positive. So all you have to do is look at the calculator, say, okay, where is r positive? Well, it's positive here. This, state the intervals where r is increasing, r is decreasing, okay? What it means by this is the slope going to 0. Is it going to change directions? Okay, let's see if I can explain. The interval is going to increase when the function is going towards 0, okay? So what I mean by this is let's have a normal function like this. R goes up to the maximum point, it goes down to the 0 point, it comes down to this minimum point, and it comes back up to here. Now, there's 2 points on this graph where r is increasing, and it's going to be from right here to right here to right here to right here, okay? This little area and this little area. Now, why is that? When r right here is starting at a slope of 0, when you hit this point right here, it's the slope of this actual point right here is 0, all right? And so what it means to it's going to start from 0 and it's increasing. So if you need to remember this, the interval is increasing when it's going from a maximum or minimum point to a 0. So this point is here at a maximum, starting at the maximum point and heading to the 0 point. It's decreasing when it's going from 0 to a minimum or maximum. So this point right here, it's decreasing. This point right here, it's decreasing. Why? Because it's heading towards the maximum point. Why? Towards heading to the minimum point. So let's just remember that. Increasing from max or min to the x-intercept decreasing from 0 to the max or the min. Okay, that's all I have to remember for this. Say the intervals, the distance of r from the pole is increasing. The pole is just 0. So where is it increasing when y, is it increasing from y equals 0? So it would just be the inverse of the increasing or decreasing. But if that's too difficult to understand, let's draw our graph again. Draw it right here. When it's going from the 0 to the maximum point, it's increasing. When it's going from the 0 to the minimum point, it's increasing. When it's going from the maximum point to the 0, it's decreasing. When it's going from the minimum point to the 0, it's decreasing. Okay? That one. Just remember, the intervals where the r value slope is increasing, it's increasing from the maximum point to the x-intercept, and it's decreasing from the 0 point to the maximum or the minimum point. Increasing from the max to the x-intercept, decreasing from the intercept to the max point or the minimum point. This one, okay. Let's take a look at De Moivre's theorem. Let me see if I can pull this up on my De Moivre's theorem is somewhere. My apologies, I'll probably skip through this part. This right here. De Moivre's theorem. Okay. De Moivre's theorem. Z equals R cosine plus I sine. Complex measurement. Okay. So, if it's written like this, what does it want you to do? It wants you to get your answer into A plus B form. All right. So, let's look at the example in this problem. It wants me to write this equation into standard form, which is this. So, what do? It's not that difficult. You go z cubed equal, how do you think you do that? Yeah, you know how to do that. You just all you do is you distribute this 3 here. Z equals 2 cubed. And then you put the whatever this number is, you times it by whatever these are. So if instead of cosine of pi over 6, you're just going to put because the equation for De Moivre's theorem is this. Z equals R to the nth power. This is n. This is the n power. Times cosine. And then n times whatever the number is here. Or they do theta. Plus sine of n times n. So n is this. So for this equation, it's going to be z equals, the r value is just this. The value in front, this is the r. So 2 to the 3rd times cosine of 3 times pi over 6 plus sine of 3 times pi over 6. So z equals 8, and this is just going to be these things. And so now that we know that when we distribute it out, it's cosine times pi over 12. Now we need to find out what is the unit circle value when the unit circle is at pi over 12. What is the x value? All right, so let's think back to our unit circle. This is pi over 2. It's going up totally, so there's no value. So it's just going to be let's go back to this cosine cosine of pi over 2 is just 0. 0 times that plus I. The I comes from here. Didn't put it in here, but you know it's there. Doesn't really matter. Times I of 1. 8 equals, what is 0? 8 times 0? 0. What is 8 times 1? 8. So Z equals 8I. So to recap, the Morse theorem just says you take the exponent value up here, you put it into the parentheses and multiply it by these theta values here. So in our case, 3 times pi over 6. You FOIL this all out, and then you take the unit circle values of the cosine, which is just the x, sine, which is just the y. You take the x and the y values of these numbers, you multiply it by the number out here, and then that's all you do. So not that hard, at least I think. Yeah, that's what you do. Describe the relationship between. This isn't really easy. You don't even need a calculator for this one. The first thing, h of x equals 2. You're just figuring out how are h and g different. So 2 sine 3 of x. So what's different here? Well, the amplitude is added by 1 on this one. So you just say amplitude is bigger by 1, whatever. And it's going to be on the multiple choice, so it'll say that. And then what else is different? Well, it's shifted left by pi over 6. That's all you have to do. You just have to notice what's different and then say it. Remember that positive is left, minus is right. This one is also really easy. All you have to do for this one is it's negative and it's going to be positive infinity, and then just put in the negative value of whatever this amplitude is, put in the positive value for whatever it is. And so if the amplitude is 3, then its range is going to be negative pi, negative 3. And this is because the secant values, the only things you're graphing are like the parabolas, remember? Because it's like this, and so your parabolas are like right here, goes like nah, and then goes like nah. So you're just graphing the range, which is the y values of this. So negative 3, negative infinity to get there to that. Negative 3, and then it's going from here. Well, it starts at 3 and it ends at infinity. So that was not that hard. This one's kind of difficult, and we can run through this one. So this one also, we have to look back at another identity thing. See if I can find it in the workbook. Way back there. Okay, back to this. Let's remember back to 2 sine 2 u. I'm just going to do it on this because I don't feel like doing it. So the equation was sine 2x equals 2 cosine. Well, when it's the 2 is next to this x, it's not outside the x, then it becomes this, and this will be on your test tomorrow. So all you have to do is plug in this for this instead. So 2 times sine of cosine equals cosine of x. And then you'll subtract the cosine to the other side, whatever. So it becomes 2 sine cosine minus cosine equals 0. Factor out the cosine because there's 2 cosine. There's a multiplication cosine here, and there's just a regular cosine here. So it becomes cosine 2 actually you have to do 2 cosine because technically it has to be 2 cosine. Because technically, even though the 2 is here, it's also 2 cosine. It's not just 2 sine. It's 2 cosine and it's also 2 sine. So factor out the 2 cosine, and then it'll just be sine minus 1, because obviously... Actually, no, fuck. I'm totally wrong about that. I apologize. You don't factor it out because there's not a 2 in front of this cosine here, so I couldn't do that. I can only factor out cosine, so it just becomes 2 sine. It just becomes 2. Why is it 2 cosine? Oh, I'm an idiot. I'm a total idiot. My apologies. I'm writing this whole thing wrong. I was like, I'm missing something here. Okay. This would just be 2 cosine. I don't know why I didn't write it. Equals 2 cosine. 2 sine times cosine squared. Subtract to the other side, so it becomes 2 sine of x cosine of x minus 2 cosine of x equals 0. Take out the 2, factor out the 2 cosine, and then it becomes just sine of x minus 1. Doesn't become 2 sine of x because you're getting rid of the 2 and the cosine. So the sine gets rid of, it's negative 1 because 2 times sine cosine. Now you're factoring out, it's the same thing. So you just get that. And now let's put these equal to 0, like we did that in the last, that other equation, 2 cosine equals 0. So divided by 2. Where does cosine equal 0? Well, cosine equals 0 at pi over 2 and 3 pi over 2. So that's one of our answers. And then let's go back to this, where sine x minus 1 equals 0. Where is sine of x equal to 1? Well, that's also 3 pi over 2 and pi over 2. So our answers would just be x equals pi over 2, x equals pi over 3. Hopefully that makes sense. If that doesn't make sense, just remember that you're going to have, if it's in the thing, doubling angle theorem, you subtract this number to the other side. Likely, you're going to factor out a number because there's two cosines here. Then you just set both of these equal to 0. Find where the unit circle value is for that specific thing. So if it's sine of x, where is sine of x equal to 1 on the unit circle? Pi over 2. Where's cosine of x equal to 0 on the unit circle? Pi over 2. Pi over 3 pi over 2. And yeah. I hope that helps. If you have any questions, let me know.